Hi students, welcome back to the tutorial class. We continue with the 3.1. So I call you to go back to do is it. So now we go and see the answer. Okay, this one is an objective. I think I want to discuss some of the objective question. Okay, let's see number one. Number one, the answer is a B. Okay, how to get B? Okay, first one, you go and see the wire, the current, how to flow through the wire. The current is flows downwards. They flow downwards, so we're using right hand grip rule. So when flow downward, then we point down. So how the magnetic field? The magnetic field is a clockwise. So clockwise means like this. So if I put the compasses get surrounded with the wire, so we find it the rotation. They follow the clockwise. So at the top, they will go to the right hand side. Then the right hand side one, they go to down. Okay, after this one go to left, then this one go to up. If we follow the direction they show in the question, so that means this one when you put to the right hand side the compasses, so you find it the compass will go downwards. The arrow will point to the down. Point to the down means what? Okay, point to the down means there's a east. Okay, follow this question. So that means your answer should be B lah. The pointer they will move to the east. Okay, then we go to question number 2. Number 2, the answer should be A. Okay, now we see why the answer should be A. Okay, first one, we're going to see the current, how to flow. The current is up. Okay, the current flow up. So if flow up means anti-clockwise. So anti-clockwise, now we take all the compass surrounded with the wire. Okay, we find it the rotation is anti-clockwise. So you can see this one is go to left, this one is come down, this one go to right, this one is go up. So these two is represent the M and also the N. Okay, before that, they show you the M and N also point to the right, is it? Finally, later the M will deflected, go up. Okay, how about the M? M will deflected, come down. So that means we need to know the direction. So before that, the N is right, is it? So before that, the M also is right. Okay, these two is go to the right. Okay, now, okay, these two, they go to the right. So later what happened? Later this one, they will deflect up. So that means they will turn up. So they turn this side, go up. Okay, how about this one? This one is right hand side, is it? Later they come down. Come down means they turn, point downwards. So one is turn up. One is like this. Okay, they point up. So this one, the M is like this, they turn down. So that means M and N is move in opposite direction. Yes or no? One turn up. How many degrees? 45. 90. Not 45, 90. Okay, another one is like this. Turn downwards. Also 90 degrees. So that means the answer should be A. A, how to explain? Both compasses deflected 90 degrees in an opposite direction. Okay, both also got rotate. How they rotate? One is rotate anti-clockwise. One rotate clockwise. How many? 90 degrees. So both in opposite direction. Okay, number 3, the answer is a coin. Okay, number 4. Number 4, now you see the direction. Okay, you must label. Label in the diagram. See how the current floating. Okay, this one is a diagram. Okay, you see the positive. Okay, when the positive, the wire is up and down, up and down, up and down. So you find it how to grip like this. Okay, the current is come out. So you see my finger is point outside like this. So that means thumb is go to right. So thumb is a right hand side, there's a north pole. Okay, if I say north pole means when I draw the direction, okay, when I deflected, so the direction must be go up. Okay, must be go up because there's a north. North direction of the charge must be go up. Magnetic field, not charge, there's a magnetic field. So the magnetic force, the direction must be go out. So the answer is A. Okay, then this number 5. Number 5 also same. They show you the direction, how they grip. Okay, how the solenoid of the P and Q. Okay, P is up. So we point like this lah, up. Okay, the current is up, so you grip. So this one is a coin, it's a core. So now you go to grip. Okay, after grip, your thumb is go to left. So that means P is a north. Q should be the south. Okay, then we go to another side. Another side, the current is come down. Now the current flow down. Just now is grip, is it? Now the current is you grip up. Okay, when you grip out, your thumb is going to right already. So another side, there's a north. So your answer become north, south, north. So the answer is donkey for number 5. Okay, number 6, I think you can try yourself. The answer is donkey. Okay, after that we got 7. 7 is a C. Okay, number 8. Okay, I explain number 8. Okay, number 8, you say the wire maybe they closer because the wire very close, is it? We cannot see which one and which one. Okay, never mind. So, 2 nail, iron nail, they put together in the same location, yes or no? So that means that location, either north or either south, they both nail must be same pole, yes or no? So when they are same pole, you tell me what happened. When same pole, they will repel each other. Yes or no? I don't care there's a south or there's a north. How they move, never mind. Okay, important you are one of the pole. Then when 2 also is the same pole, means 2 must be repelled to each other. Okay, so now we find it. When the current flow to the solenoid, what happened for the nail now? Okay, the nail both will repel to each other. Okay, so because they are solenoid, when the solenoid together means you get the same of the pole. Okay, number 9, which one should be correct? The answer is A. Okay, you try one by one. A, B, C, D, you must go to try the direction. Okay, after that, number 10 is a C. Okay, then 11, there's a donkey. Okay, 12, there's a boy. Okay, then we go to 13. Okay, let's see 13. 13, they show you the diagram, okay, of the core for an electromagnet. They got 4 different of the metal rod. Okay, now we try the metal rod. Because they got iron, later they got copper, later they got steel. Okay, we see which one is most suitable to become the electromagnet. Okay, now they say table below, they show the number of the clip, paper clip that attract to the metal rod when the switch is turned on and also turned off. So now, which one, A, B, C, D, suitable become the core of electromagnet? So from here, core of electromagnet, actually we have to choose. Is it that attract more is a good? Okay, we never say like this. If you attract more means what? Your electromagnetism is very strong. That one is the meaning. Okay, electromagnet means I want you to become temporary magnet. So that means when you become magnet, you can attract. When you no more current to pass through, that means you are no more magnet. So they will lose the magnet. That one is an electromagnet. I don't want you become the permanent magnet. I just want temporary. So from here we go to check. When turn on, okay, the first one A. When turn on, you attract 40. Okay, number of the paper clip that attract 40. Okay, when switch off, that means number of the attract 35. That means you release how many? You release 5 only. So that means when I off, you still magnet. So you still attract. Okay, then you test number B. B is turn on 38. Okay, when off, you still got 5 attract. That means you lost 33. 33 will fall down. Okay, C, you attract 25. When I off, you still got 4 attract. That means you drop 21. Last. When I switch on, then you attract 1. When I off, nothing. So you tell me which one good for become the electromagnet. The answer should be donkey. The answer not B. Okay, B means maybe the B is a permanent magnet because you can attract many. Okay, you also can release many, but finally you still attract something. So that means when I switch off, you still a magnet. You cannot lose all. Okay, so that one we call it you are not electromagnet. So if the situation say, okay, I want to attract more, what to do? If you're using electromagnet like the donkey 1 and 0, you attract so less, what to do? So how to increase, you attract more of the paper clip? So now we're thinking about a factor lah. Maybe I increase my current. When I increase my current, maybe I can attract more. I also can immediately release. Okay, understand? So different thing. If the question they ask, which one more suitable become electromagnet? So your answer is donkey. If the question say, which one become very strong? of the magnetic field? The answer may be B lah. Okay, if they never say which one is an electromagnet, if they say A until D also electromagnet, so they ask you which one is the strong, high of the strength, so the answer should be B. So if the question never says the strength, they just say which one most suitable become electromagnet, your answer must be donkey. Okay, they can attract, they also can be released. Okay, then we go to the structure. Okay, let's see the structure one. Okay, structure one, they show about the compasses that placed on the horizontal cardboard. Now a straight wire passes the current center of the cardboard. When the current switch off, okay, all the compasses needle, they point to the north. So the mean up is represent to the north. Okay, now we go to A. Okay, let's see the diagram below. Draw the arrow to show the direction of the needle when the current flow through the straight wire into the cardboard. Okay, flow through. Flow through means go in. Okay, go in means cross. Remember, I teach you cross means far away from you. Dot means come to you. So now it's far away from you. How to point far away? Okay, far away you can point like this, far away, or you say point down means far away. Okay, point down means clockwise. So if I draw the compasses clockwise, how to draw? Clockwise means this one go to right, down, left, up. Okay, this one we call clockwise. Okay, you can draw. Okay, then we go to B. Okay, current pass through the coil P and Q. For P and also the Q. Okay, now the circles that represent the compasses. These two is a compass. Okay, first we do know how the direction. We just empty first. Okay, then the question calls you to draw the arrow, the circle to show the direction of the compasses. Okay, then number 3, they call you to the coil PQ act as a magnet. So state the magnetic polarity of the P and Q. So the first step, we need to know the current how to flow first. Okay, you show the current how to flow. Okay, now follow the diagram. The current is up. Okay, because this one positive. When they go up, they turn. Okay, this one is the direction of the current. So we're using our right hand grip. Okay, this one is a solenoid. So like this, I just grip. Okay, this one is my current direction. So I go to grip. So when I grip, my thumb is point to the left. Means understood this part is a north, this one is a south. Okay, understand? So now they call you to label. Okay, you label the arrow in the circle, show the direction of the compass. So north. Okay, north. Okay, direction, go out. Okay, remember, every time when we draw the line, the direction must be follow the north direction. Okay, the south like this. Okay, the south direction is go in. North direction is go out. Okay, so now the following is PQ act as a magnet. State the magnetic field polarity P and Q. So we mentioned P is a north pole, Q is a south pole. So you label N and S. Okay, C. On the diagram, sketch the magnetic field line around the inside of the coil PQ. P and Q inside, you need to draw the line. Show the direction of the magnetic field line. So we show the direction. Okay, come we draw it. Okay, first one, you go straight. Okay, after that, you go to turn. Okay, then the next one, if you want to turn outside, then you turn outside. Can see or not? Okay, if cannot see, I can redraw. Okay, wait, I redraw first. Okay, this one as your diagram. Okay, before we draw the magnetic field line. Okay, this one's a north pole, this one's a south pole. Okay, they draw the center. One straight line. Okay, after that, we got curve a little bit. Okay, after that, the center here should be rounded. Okay, now we draw the direction. North pole is out. This one is in. So this one should be go out. This one must be go out. Okay, so if never turn, we just draw like this. Okay, this side to this side. Okay, so this one is a magnetic field line. Okay, you show the direction, then you show the pole. After that, you label to show the current how to flow. So that one is B question until C. Okay, then we go to question SPP 08. 2.1, they show the simple electromagnet. Okay, they use for lifting the releasing the small meter ball. Okay, now they got solenoid also. Now in the diagram, mark the direction of the current flow in the solenoid. So we need to mark it. Okay, let's see the diagram. Okay, when I just close the switch, so we draw the current first. Okay, the current is start to flow. So that means if follow here, the current must be like this. Okay, we follow the information, then from back, then come back. So now, after we label the current, now the question B1 they ask you, name the magnetic pole, the end of the core of the P when the switch is on, P. So from here, we also using the right hand grip to find the pole. So that means now this one is a soft iron core. How I grip? So this one is to represent the magnetic field how to go. This one is represent the current how to flow. So now I using this one, my finger, grip. So is it like this? I grip. So the current is grip like this. So I grip it. So you see my thumb is up. So understood, this one is a north pole. So P is a north pole. So we just answer B1, that's a north pole. Now they ask you, state the rule you use to determine the pole. So we're using right hand grip rule. If you're using Maxwell, it's up to you lah. Normally we're using the right hand. Okay? Okay, for this one, Maxwell cannot use. Maxwell just using for the current straight line. Okay, but this one is a solenoid. So solenoid must using the right hand grip rule. Okay, then we go to the next one. Okay, number 3. Okay, they say based on the solenoid in the diagram, can you draw the magnetic field line that form around the solenoid when the switch is on? In the diagram, show the direction of the magnetic field line. So that means from here, you need to draw the magnetic field line. So we know this one is a north, this one sure is a south. Okay, now we draw the magnetic field line. Okay, first one. Okay, center, we cannot draw anything because there's a soft iron core already. So we just can draw is surrounded. Okay, make sure don't cross. Surrounded, magnetic field line. Okay, so from here, north to south. So you just draw north to south. Okay, this one is in, this one is out. Okay, depend how you draw the line. How many is up to you. But important, surrounded with the solenoid. Surrounded with the solenoid, we got magnetic field line. Okay, so how many is depend for yours lah. So normally we draw the line is more than 1, 2 like this. After that you label the direction. Okay, then finish, then we go to C. Okay, C they show you the table, the suitable properties. Okay, to be the chosen to build the electromagnet, state the reason for your choice. So this one same like the essay question, but they got short only. They don't have 10 marks. They may be 6 marks or 4 marks like this. Okay, a little bit lah. So from here we see the number 1, material used for the core. So everybody know lah, material used for the core, we just choose the soft iron core. Okay, when I choose soft iron core, then the region should be 1. Okay, before that I told you already, if I'm using the soft iron core, the reason is easy to magnetize and demagnetize. You can find inside the notes. Okay, easy to magnetize and demagnetize. Okay, then number 3, the shape of the core. So from here we choose from here. We got three shape of the core here. Okay, one is a cylinder straight. Okay, after that got U shape also. Another one also U shape, but thin a little bit. Okay, so which one? They ask about shape. They never say about the thin or thick. So from here we choose this U shape. Okay, we choose the U shape. So you need to give the reason why you choose about the U shape. Okay, so from here you can go back to see your notes here. Okay, page number 2, the last one, number 4. Okay, why we using the U shape? So from here, the U shape, the function is the magnetic field line has concentrate in the space between the pole. So that means if I'm using the U shape, I can concentrate all the strength of the magnetic field at the center. So that means they will become stronger. Okay, so from here I can write the answer here. or you just listen, I'm just talking short sentence only. Concentrate the strength of the magnetic field. Concentrate the strength of the magnetic field. Okay, at the center. Okay, so that one is the reason why we choose about the U shape. Okay, let's see the D. Okay, D, electromagnet. Okay, this one is what electric bell, is it? Okay, electric bell. So from here, they call you to explain the working principle of the electric bell. Okay, so from here, you can refer your notes. Okay, I can tell you the number first. Okay, number 1, sure they show about the battery. So that means you must switch on your battery. Okay, when you switch on the battery, number 2 is can you see the U shape, the soft iron? So you must say, now the soft iron become electromagnet. Okay, when they become the electromagnet, then can you see the soft iron armature? So number 3, you must say, now they will attract the soft iron armature. Okay, when they attract the soft iron armature, after that you go number 4. You can see the hammer. The hammer will hit the gong, okay, and produce the sound. So after that, the last one, you can see the contact screw. At the same time, you must add the word at the same time. The contact screw, they will be broken. Okay, because when you hit the gong, the contact, they will be broken because you pull already. Okay, so you must say at the same time, the contact screw broken. Okay, then the soft iron armature go back to the original position. Then you say, now the current circuit flow through again. Okay, when the soft iron armature go back, that means now the contact join back. Okay, now the soft iron armature, they will go back to the original position, then the contact will join back, then the current flow through the circuit again. Then last one, the process is repeated until the switch is off. Okay, so this one, I don't want to write anything here. I want you to explain by yourself. Okay, all the answer in the notes ready. So I just want you refer the diagram. Before you start, you label in the diagram 1, 2, 3, 4. Okay, after that, based on 1, 2, 3, 4, use your own sentence to create. Okay, the keyword is there. Okay, example number 1, the keyword. Switch on the power supply, or you say the battery is there, then after that the switch is on. Okay, number 2, current flow through the circuit, soft iron magnetize. Okay, soft iron magnetize and become electromagnet. Okay, number 3, electromagnet will attract soft iron armature. Okay, and the hammer will hit the gong and produce the sound. Okay, at the same time, contact screw. Okay, contact screw with the soft iron armature will broken. Okay, connection for the contact screw and also soft iron armature will broken. So from here what happened? No current flow through the circuit. When it just broken, no current flow through the circuit, then the spring will pull the soft iron armature go back to the original position. Okay, so now the contact join back. Okay, now the contact join back again. So the current flow through the circuit, then this one process will be repeated. Okay, until the power supply, or you say until the switch is off. That's all. Okay, this one is a process. Okay, then we go to the last one. There's a E. Can you state the 2 ways how to increase the loudness of the sound of the electric bell? So from here we know how we increase the electric bell becomes stronger strength. So the first one, you want become louder means the hammer must be hit very strong, is it? So the hammer hit very strong. The first one you must say, you increase the current. Yes or no? You increase the current means you pull the soft iron armature faster, stronger. Okay, number 2, you must say you increase the number of turn. You increase the number of turn means now your strength of the magnetic field also becomes strong. Okay, last one, some student will say, if I make the hammer become bigger, also can. That one is the logic, the common sense. If you make the hammer become bigger, or you make the bell, the gong become bigger, you also produce the sound is stronger. If we follow this one topic, okay, using the magnetism, so that means first one, increase the current. Okay, number two, increase the number of turn of the soft iron. Okay, so this one is a tool how to increase the strength of the magnetic field. So that one is related to the factor, how we using the 4 factor to increase the strength of the magnetic field. Okay, so from here we finish our tutorial. So the next lesson should be the 3.2. 3.2 also using the hand. Okay, so we're using the right hand or left hand. Later I will introduce. So from here, you can recall back the tutorial. If you don't understand, you can PM me to ask the question. Okay, thank you for your watching.